this video, we will look at real numbers and their properties. S equal to set -12, -7.25, negative square root of 3, -5/6, 0, 0.45 repeating, root 3, 21/3, and 999. List the elements of S that belong to each set. How many or what are the numbers out of set S that are natural numbers? Natural numbers are just a counting numbers. So the square root of 9, which is 3, is a counting number. 21/3, or 7, is a counting number. And 999 is a counting number. Whole numbers are natural numbers with the addition of 0. So the whole numbers that are in set S are the same as the natural numbers, as well as the number 0. Which of the values in S are integers? Integers are our negative and positive whole numbers. And remember, that also includes 0. So we have -12, 0, the square root of 9, or 3, 21/3, or 7, and 999. Which of those are rational numbers? Well, it turns out a rational number can be thought of in two ways. One way to think of a rational number is anything that I can make look like a fraction. So most of those numbers can easily be made to look like fractions by putting a 1 under it. Now the fraction has to be made of whole numbers, top and bottom. It can be negative though. Another version of rational numbers is repeating decimals, for example 0.45 repeating, or terminating decimals like 7.25. So basically everything up there except the negative square root of 3 is a rational number. I can either make it look like a fraction by putting a 1 under it, or it's a terminating decimal or a repeating decimal. That means the irrational numbers are just 1, and that's the negative square root of 3. Now real numbers are any numbers that aren't complex, like I. If it doesn't have an I in it, it's a real number. So we have all of the numbers there are real numbers. Evaluate each expression and identify the base and the exponent. Well, 10 to the third power, 10 is the base, 3 is the exponent. The meaning is 10 times 10 times 10, which is equal to 1,000. For example, B, we have -3 to the fourth power. Now you do have to be careful with negatives. The addition of the parentheses there make it very clear that we're taking -3 and multiplying it by itself 4 times though. So we get a positive 81. On part C, it's a little less clear. What does that negative mean? Is it attached to the fourth power or not? Well, it turns out it's not. That negative is separate from the 3. So that negative hangs out, and we take 3 times itself 4 times, so we get a -81 for an answer here. 2 times 5 squared, 50. 2 times 5 squared is 100. So it's important to pay attention to things like parentheses or not. Now, order of operations, remember we do parentheses first, followed by exponents. Then in order from left to right, multiplication and division. And then in order from left to right, addition and subtraction. So the first thing we're going to do is take 2 to the third power. That's an 8. So we have 6 divided by 3 plus 8 times 5. We don't have any parentheses or exponents, so now we work from left to right looking for division or multiplication signs. So we take 6 divided by 3, then we take 8 times 5, and now finally we can add. Parentheses, exponents, multiplication, division, addition, subtraction. So parentheses first gives us 25. No more parentheses or exponents. So now left to right, I multiply and divide. So 25 times 3. Then I divide, and now I finally add. Same thing here. Think of the numerator as something in parentheses and the denominator as something in parentheses. So the numerator first, we have exponents up there. 2 to the 4th is 16. Then 16 minus 11, that would give us 5. On the bottom, we have 3 times 2 is what we would do first. So we end up with 5 over 15, which simplifies to 1/3. A lot of negatives in here. Remember that negative on the 7th square just kind of hangs out. So we end up with negative 49. There's nothing really to do inside the parentheses. So after we deal with the 7 squared, now we just go about multiplying, and we end up getting negative 49 plus 9 over negative 18 plus 2, which simplifies to 5/2. Sometimes evaluation can mean replace values with some number. So we're going to replace A with negative 4, B with 3, and C with negative 6. And now this turns into an order of operations problem, and we get 129. Same thing here. A gets replaced with negative 4, B gets replaced with 3, and C gets replaced with negative 6. You do have to be careful that you're following the order of operations. And when you get done, you should get a negative 21 here. We're going to skip that example. We're going to skip this example. I don't think you need to go over simplifying expressions. Distributive property should be well known to you. This is an interesting take on the distributive property. We're kind of working backwards. Absolute value is distance from 0, and that's why absolute value can never be negative. That does not mean you can't get a negative answer, though. For part A, we're asking how far away from 0 is negative 6.85. Well, it's positive 6.85 because it's a distance. For part B, we're asking for the distance away from 0 and make it negative. So that's why the answer is negative 50. Same thing for part C. How far away from 0 is negative 2/3 and make it negative. And then how far away from 0 is y if y is the square root of 2, so we get the square root of 2.